Uh, really, when we say exponents, so when we have multiple addition, we get multiplications. So we add many things together, that's multiplying. So what happens when we go multiple multiplications? So we multiply some things a lot of times. Multiple multiplications. That's a mouthful. Well, that is when we have exponents. So essentially, it is like the same value multiplied many times. And that is what exponents are. So 5 to the 2, that's equal to 25. Well, first that's equal to 5 times 5. And that's equal to 25. Yeah, so this dot over here is also a symbol of multiplication. So then, with this, we actually give some kind of name to this here. For example, is called this here is actually called the exponent. So that's what it is. And then the 5 over here, like this number at the bottom, this here is called the base actually. So I'll use a different color, maybe like blue. Yeah. So this here is the 5. The 5 is the base. So the base is the value that you multiply by, and exponent is how many times you multiply this base. So with this, we can have, so just like 5 to the power of 2 to the power of 3, these are easy. You just do it like 5 times 5 or 5 times 5 times 5. They're all pretty easy. If the numbers get really big, all you need to do is use a calculator and you can get it. But other than that, we can actually like come up with some properties or formulas, whatever you want to call it. Some tricks to help you with multiplying or simplifying, as we sometimes like to call it. So these are what are these? Yeah. So exponent. Exponent rules. So the first thing is something like this. So x to the m times x to the n, that's equal to x to the power of m plus n. So for example, 5 to the 2 times 5 to the 3. Now by this, the top row over here, 5 is the base, so that's x. So that one stays the same. And then you essentially add 2 and 3. 2 plus 3, and that is equal to 5 to the 5. Now, so that essentially is an example of the top over here. So why does this work? Well, if you break it down, 5 to the 5 is 2 5s multiplied together, right? And then 5 to the 3, that's, so I'll bracket this, although it's not necessary. 5 to the 3 is 5 times 5 times 5. So this is 2 5s multiplied together, and this is 3 5s multiplied together. So when you multiply them all together, you're gonna have 5 5s multiplied together. So 5, uh, so since exponent is multiplying the base by a number of times, right? So when you have 5 5s, that is essentially saying 5 to the 5th exponent. So that is a really big number, and of course I can use a calculator to find it out. That is equal to 3,125. But since this is quite a big number already, oftentimes we just leave the answer at this. So, like if you give me, like if I ask you what's 5 to the 2 times 5 to the 3, I don't need the 3,125. I only need 5 to the 5. That's all I need. But then, of course, so like what is the borderline? Like when do we only put it in this, and when do we like find out actual number? Like 2 to the 2. Well, that's equal to 2 times 2, and that's equal to 4. Like you don't need to leave it at that. You can just like tell me it's 4. Like 2 to the 2 is obviously 4. Let me just get rid of this. But then 5 to the 5, that's not so obvious. So like for that, like when do we use the exponent? When do we actually find out the value? Well, usually we like 2 to the n. It's always good to remember what the values are. So like 2 to the, so and then like let me make a table here. So these are some values that would be nice to remember. So 2 to the n. Well, when n is, I will leave 0 first. 2 to the 1. So 2 times by itself 1 time. That's equal to 2. When n is 2. 2 to the 2. That's 4. When n is 3. Oh, I'll write this out. Equals to 4. 2 to the 3 is equal to 8. And when n is 4, 2 to the 4, 16. And then 32. And for like for the exponents when the base is 2, it's often nice to go all the way down to say this is 64, and then this here is 128. Yeah, so like maybe to 8, yeah. So 2 to the 8 is 256. So like any like n less than, for like when you have 2, like any n less than 8 or equal to 8, I think it'll be really nice to remember these numbers. So 2 to the 5, like just when you do enough questions, it should just come to you. Oh, 2 to the 5, 32. Because it's, so you can check that with the calculator. 2 times 2 times 2 times 2 times 2. 5 times. That should give you 32. And same with everything else. So like for 3, so sometimes when we have the base 3 to the n, oh, 1, 3 to the 1 is always, anything to the 1 is always itself. And then 2, 3 to the 2 is 9. 3 to the 3, that's 27. 3 times 3 times 3. Check that if you want. And 3 to the 4 is 81. And that's usually as far as we go. When you get like a 3 to the 5 as an answer, I'll be fine with just you just giving that answer to me and every other teacher as well. But anything equal or less than 4, I think it will be good, like for 3 to actually calculate it. And then like we go 4, and then 4 to the 2. 4 to the 3 is 64. And I actually don't quite remember what 4 to the 4 is. So, oh, it's 256, yeah. Yeah, so, yeah, usually we don't need this. Nobody really cares. And then, yeah, you can just keep going to do 5 to the n and 6 to the n. I can actually leave this as a homework to you. So for n less than or equal to 4, find out all the 5, 6, 7, 8, 9, 10. Yeah, no, 5, 6, 7, 8, 9. Just find like 5 to the 1, 5 to the 2, 5 to the 3, 5 to the 4. Just like that. And so going back to here. So x to the m times x to the n, that's equal to x to the m plus n. Now with multiplication, we can have this. But then now if we do, oh, sorry, I didn't. Wait, what can you guys hear? What can you guys hear? Not hear. What was the last thing you guys heard? Oh, okay. Yeah, I think it might be my network. It's not really good. Sorry about that. What did you guys hear about this part? How? Like this part? Can you see anything right now? Oh, yes, yes, okay. But you didn't see this, right? This. Okay, that's okay. It's not really important. But yeah, this part is the most important. As long as you heard this, it's fine. Okay, I will keep going. And I guess I will check the chat more often to see if my network goes bad again. So when we divide, so let's say I have x to the m divided by x to the n. Now that is equal to x to the m minus n. So, example. Let's say 3 to the 8 divided by 3 to the 2. Well, if we use the property up here, that is equal to 3 to the 8 minus 2, and that is simply 3 to the 6. Now, how this works, right? So if we look at this fraction, this division, it's essentially a division. I'm going to write it all out. So I have 8 threes multiplied together. 6, 7, 8. And now I divide it by 3 to the 2. So that's 2 threes multiplied together. Well, when you have division, and if the top is the same as the bottom, you can cancel it out. So here I go, and cancel out 1 3 with one of the top threes, another one with another one. So how many are left? 1, 2, 3, 4, 5, 6. There you go. 3 to the 6. So why this works is essentially because you're dividing this from this. So if you expand it out, when you expand everything out, you're essentially like canceling, right? You see how I just canceled it here. So like in this example, there are more more at the top and less at the bottom. So that means when I cancel it, there will be the fraction will only be left with the top 3's, and there are 6 of them here. And why? Well, exactly because of this rule. X to the m divided by x to the n is equal to x to the m minus n. So does this make sense? And intuitively, I hope it also makes sense to you. Because when you divide something, like when the top is bigger than the bottom, right? Then the result will be smaller. And so when you minus, well, when you minus, the number will be smaller. So 3 to the 6 is less than 3 to the 8. So that should make sense because the number just got smaller. Like 6 divided by 2, that's equal to 3. That's less than 6. So division, it makes the number smaller. And okay, so you got x to the m times x to the n is x to the m plus n. And then the second one is x to the m divided by x to the n is equal to x to the m minus n. Now, and then, so the third one is actually, the third one is x to the m. Now, when this whole thing is raised to the power of n, that is equal to x to the m times n. So m multiplied by n now. So example, 4 to the, say 4 to the 3, and this whole thing is raised to the power of 5. No, that's too much. 5 to the power of 2. If we go by this property up here, we have that is equal to 4 to the 3 times 2. So 3 times 2 is 6. So this is equal to 4 to the 6. So why does this work? Well, again, you can expand this out. So 4 to the 3, that's equal to 4 times 4 times 4, right? Simple. But then everything here is raised to the power of 2. So what does this mean? That means you're essentially multiplying all these 3's another time, once again. Because that's what the power of 2, that's what it means. So you multiply it again by a, so you have 3 4's over here. 3 4's multiplied by 3 4's. So 1, 2, 3, 4, 5, 6. Now you can just count it up, and that's equal to 6. So essentially, you like what this is saying is that you have n groups of x to the m. So like here, there's 2. So there are 2 groups of 3 4's. 2 groups of this. If this is instead 5, then there will be 5 groups of these. Right? So if instead it is 5, then there will be 5 groups of this. 1, 2, 3, 4, 5. And this here, now what is it? Well, there are 3 in each group, and there are 5 groups. So it's 3 times 5. And that's equal to 4 to the 15 now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The inside is the inside number, so m here, is the number of base, so 4 is the base, in each group. And the n on the outside is how many groups there are. So this is why this becomes like multiplication. So whereas this one, when you have just x to the m times x to the n, that's addition. But here, it actually becomes multiplication with exponents. So like previously I was saying multiple additions is multiplication and multiple multiplication is exponents. While even within exponents there's like a difference between multiplication and addition. Yeah. So oftentimes, right, like if you can imagine, writing it this way is always bigger than this. So writing it this way. So like x to the 3, all of this to the 5, that's equal to 4, 4 to the 15. But if you do it this way, it's only 4 to the 3 times 4 to the 5, and that's only equal to 4 to the 3 plus 5, which is only 4 to the 8. So, yes. Let me write this better. So, these are the 3 really basic ones. And now with this, one more thing I just want to quickly talk about today is x to the 0. X to the 0 is not 0, is equal to 1. So you have any number, so 3 to the 0, 5 to the 0, 6 to the 0, 125 to the 0 is all equal to 1. That's the other key thing you want to recognize. So why is this not 0? Well, because like we are dealing with exponents here, so everything is multiplication. So like if you have nothing multiplied by itself, that doesn't mean there's nothing. It just means that like when 1 times 4, right? That's 4. But you can, yeah, so like this is just like how mathematicians give a name to it. And you can actually prove this by division. So like when you have 4 to the 5 divided by 4 to the 5, according to our rule over here, that's equal to 4 to the 5 minus 5, so that's 4 to the 0. Well, that is not nothing. That's not 0. 4 to the 0 is not 0. Because 4 to the 5 divided by 4 to the 5, that's equal to 1, right? Like, the top number is looks the same as the bottom number, so you can just cancel it. And when you cancel it, doesn't become 0. It becomes 1 over 1, so that's 1. So that's why x to the 0 is 1. And the other thing is, now this one I won't talk too much about it. You just got to recognize that you can have negative exponent, and that doesn't mean the number become negative. That simply means that it becomes 1 over x to the n. So for example, 5 to the negative 2, that doesn't mean it's negative 25. That means it's 1 over 5 to the 2, and that's equal to 1 over 25. So this is just like a brief lesson on exponent. Yeah, that's everything I